Good evening, everybody. This is Brent with Lykins Motorsports. A few weeks ago, well, maybe it was last week when I did the video on the 352, someone asked to do a video on a 390, and just so happens that several years ago we did a 390, another dyno mule, as I call them, just to see what experimentation we could do with different camshafts and that sort of thing. So if you hang around the FE forums, one of the mantras that everybody screams is that hydraulic roller cams can't rev, and everybody cites that 5,500 6,000 RPM is the limit. And I wanted to show everybody that a hydraulic roller will indeed pull some RPMs. We do it all the time with the small block stuff, and there's no reason why an FE can't do it. The caveat is that the valve train has to be light. FEs have heavy valves, heavy valve train, and you have to overcome that in order to get the RPMs up reliably. So with all that being said, this episode is on our 390 Dyno Mule hydraulic roller. If you want to see some 7,500 RPM hydraulic roller pulls with a 390, then stay tuned. So as with all my builds, we always start with a solid foundation. This is a C7 MEA 390 block, and standard bore for a 390 is a 4050 bore. We took this one just 10 over to a 4060 bore. I really like having the thicker cylinder walls, and if you're going to buy custom pistons, you might as well just do what you need to do there. A line honed with ARP fasteners, deck squared up, bored and honed with torque plates. Here's some shots of duplicolor engine paint going on with the timing cover and the water pump. This one got bronze lifter bore bushings. I'm sure that something needed to be corrected there. We did this one several years ago, but I can't really remember the specifics. And bronze lifter bore bushings with the 875 diameter lifter. Another shot of spraying the water pump with the block to keep the color the same. Just a factory replacement cast iron water pump. It's pretty much all you need in most scenarios. And here's a shot of some block work where we took a die grinder and hacked off a lot of the casting flash. There's another shot of the lifter bore bushings from the bottom. The bottoms of the cylinders have been smoothed out. The oil pump mounting flange has been gasket matched. So a lot of detail work that goes into the bottom end. Alright, we're moving on to the bottom end. We're using a set of custom Racetech pistons. We were using, or did use, a factory 390 crankshaft. So fairly short stroke, fairly tall deck height on these FEs. So that means that if you use a 6490 rod, that the piston is going to be fairly tall. That can be good and bad depending on which scenario you're in. Really no way around that without going to a fully custom setup with a longer big block Chevrolet rod, which I've done in the past, but you do spend a lot of money on crank work to get those big block Chevrolet rods to work on the rod journals. So this was just an exercise in seeing what the stock stroke stuff would do. For the rods, we went to Molnar. I use a lot of the rods, really light, really high quality, really high strength. You can see how tall the pistons are there, and the 8 connecting rods sitting there. Then we get the pistons and rods assembled, pistons hung on the rods. All of my stuff uses a full floating wrist pin, and on higher end scenarios we usually specify a specific wrist pin bore clearance. All use wire locks or spiral locks. And you can tell even with the piston hanging on the rod that that piston's very tall. One good thing about a tall piston is that they are very stable going down the bore. That's about the only thing that they got going for them. They are heavier, obviously. This one used a 1mm, 1mm, 2mm ring pack. Everything's going to smaller and thinner these days, and no Alice Chalmer tractor rings for this application. Pretty much in all my builds, we'll use coated bearings. If I can't get them coated off the shelf, then I'll buy a regular bearing and send it to Calico to have them coated. Here we're using some Federal Mogul race rod bearings. Crank's been turned 20 on the rod journals. So Calico coated those for me. And then we have a custom hydraulic roller camshaft going in. All the roller cams for the FEs are billet steel core. That's why they look like $1 million. And some pretty aggressive specs on this one. Lift somewhere north of 600, pretty far north, and a good bit of duration too to get that RPM up. Here's another shot of the assembled short block with the lifter bore bushings. The pistons were 4cc dome, and compression ratio with everything measured was right at 11:1 compression. I know it doesn't look like much of a well, it actually looks a little bit more like more of a dome than 4cc's, but by the time you factor in the valve reliefs, kind of cancels a lot of stuff out. Valve reliefs are symmetrical, so right there between cylinders 2 and 3, you can see they switch direction on the pistons. For the cylinder heads, we used a set of Cobra Jet heads, and used a set of SI stainless valves with the 209-165 valve package. These heads were ported. They flowed around the 290 CFM mark. Valve stem diameters were 7mm on the intake side and 5/16 on the exhaust side. That's why I'm using different valve seals depending on which valve it's on. And that is one of the keys to making the hydraulic roller stuff work. The valves are much lighter than a normal 3/8 stem valve, and obviously the lighter that you go, the higher that you can go without having much struggle. Used pack valve springs, just a small diameter dual spring with a titanium retainer. Again, trying to keep everything light on the valve train side of things. Even light springs can help. I try to stay away from big fat valve springs these days, so you won't see me use a 1/600 or 1/650, and I try to get away from the 1/550 springs as much as I can. Mr. Laws Mayfield did the port work for these heads. He's somewhat local to me, about several hours away down in Owensboro. Jeremy Mayfield's uncle. And down around that part of Kentucky is a lot of good Ford engine builders. Charlie Evans, Lem Evans, Laws Mayfield. There I'm pouring an intake port volume, and we're sitting at 162.2 cc's. So a very small port with a high flow, which is what you want for these type of scenarios. And I just noticed those were conical valve springs, not duals. Sorry for that. Been quite a while since I messed with this engine, trying to remember all the details. There's the fully assembled cylinder head. Rocker arms for this one were my own roller tip, non-adjustable rocker arms that so many of you guys have bought sets of. Appreciate your business on those things. The lighter rocker arm without the adjuster helps a little bit on the top end. We usually pair those up with precision oil pumps, heavy duty shafts, and billet stands and spacers. There's a shot of the entire rocker arm setup going on. Most definitely conical valve springs, you can see there. About a 1/800 install height. If I remember correctly, those springs set up at around 200 pounds on the seat and a little over 500 pounds over the nose with the higher RPM hydraulic roller stuff. You want to make sure that you got enough spring load to keep everything in control. Final assembly going on here, just a set of Felpro 8554 head gaskets. We're hanging the pistons out of the hole a little bit, so we compensated with a little thicker head gasket. Using a Melling high volume oil pump and a Mylodon oil pan and pickup setup. You can see there the ARP main studs along with the factory crank and the Molnar rods. Very nice looking engine going together. Stock appearing on the outside, modern guts on the inside. That's what I like. I always mock everything up before the intake goes on, so we're checking out the intake gaskets here and are checking out the lifters using Morel lifters. Some heavy duty push rods. I think these were 5/16. 105 wall was about all that I had room for with the port work and everything. But you always try to use as big of a tube and as thick of a wall thickness that you possibly can. Geometry was perfect on with this setup. You can see I was using some valve spring shims to kind of test where I needed the geometry to be, and then we switched over to my laser cut one piece shims, about a 45 thousandths pattern across the valve tip. And for the carburetors, we went with a pair of 600s from Drew Pojednik Air Fuel Spark. Choke horns milled off. And then for the intake manifold, I think I went with the wrong intake manifold. This is a BBM tunnel wedge. They are much, much larger than the Ford or the trick flow tunnel wedges, and I think that this little engine had a lot of trouble pulling vacuum on it. There's a shot of the intake manifold. You can tell how much bigger the runners are. You can physically see the size of the runners. And this one was not ported or anything. As I look back, it should have been touched up. As you'll see, the air-fuel ratios were pretty poor side to side, so intake probably should have been balanced a little bit. So up next is just a series of photos showing a completed engine, and then the engine sitting on the dyno. There's the engine sitting on the dyno at Dale Mears Racing Engines. Everything is plugged up. Spark plug wires are on. Got some super suckers on there. And what I'm going to do is I'm going to play the dyno video twice because it sounds that good. The engine really liked to rev. We were doing 7,500 RPM pulls. Starting from the left side, as we usually look at our dyno results, oil temperature just went up just a couple of degrees throughout the pull. Water temperature, we don't really mind that. Oil pressure went up through the pull. Air-fuel ratio was pretty unbalanced side to side. That's what I was referring to earlier. Torque, 460 pound-feet of torque and 543 horsepower at 7,000 RPM. So at 543 horsepower, a pretty stout little 390. Certainly not the stoutest 390 that's ever been built, but just a testament of you can make a hydraulic roller work. And there's a lot of naysayers out there about hydraulic roller cams. So with the right combination, you can get them to turn the RPM up. But a good running 390, and a testament of how really good our 352 was, making the same horsepower with about 40 cubic inches less. Alright guys, I appreciate you watching this video. Just trying to share some different builds and some different ideas and results with you. I got a lot more where that comes from, so appreciate you hanging in there. If you haven't yet, please hit that subscribe button so that you don't miss out on all this cool Ford stuff. And I'll keep putting the videos out if you keep watching them. Hope you guys are having a good weekend, and stay tuned for more stuff.